So today we are going to start on solving quadratic equations, and the first thing we're going to do with quadratic equations is we're going to factor quadratics. Typically a quadratic equation usually is presented as a trinomial, which means it has 3 terms. Sometimes it can have 2 terms, but the most important part about a quadratic is that its leading degree, or the highest exponent, is a 2. So that's how you get a quadratic, and to solve them we have to be able to factor, which is the skill we're developing today. So the first step that you are always going to want to try to do with quadratics is if you can factor out a GCF, or a greatest common factor, that makes your whole polynomial a little easier to work with. So you need to take into account the factors of your constants as well. So those are the numbers, if you want to figure out what those are, the numbers that go into your constants. Okay. So if I look at this first example, it says factor out the GCF of the quadratic trinomial. So you're just looking and seeing, are there numbers that go into 9, 12, and 36? And I would say, yeah, absolutely. All of these numbers are divisible by 3, so that would be the number that goes into all of these. So I'm going to go ahead and I'm going to pull my 3 out front. So you're factoring out the 3, and then to figure out what's left over, you can think of it as dividing each of these numbers by 3 to figure out what would be left. So if I did 9x squared divided by 3, that gives me a 3x squared left. 12x divided by 3 would give me 4x. And then negative 36 divided by 3 would give me a negative 12 left over. And you know you've done it right if you can distribute your 3 back in and end up with what you started with. You also know that you've found the greatest common factor if there are no more numbers that can go into each of these. So like there isn't a number that goes into 3, 4, and negative 12. So I've pulled out the biggest possible number, okay? So go ahead, and if you want to try the next one, feel free to do that. And now I'll keep working through it. So in this one, I look and see, is there a number that goes into 4, and into 12? And I would say, yes, absolutely. That number is 4 itself. And then to figure out what's left over, you can think of it as dividing each of these by the number that you pulled out front. So 4x squared divided by 4 would give me 1x squared, or you can just write it as an x squared. 4x divided by 4 would give me just 1x. And again, you could write it as just x. And then 12 divided by 4 would give me 3. Voila. So that's how a GCF works. One more example that I could talk to you about with this is, if you want to write this off to the side, if you had a quadratic such as like, let's do 15x squared minus 5x. Good. So this is a quadratic because the highest degree is a 2. Even though it doesn't have 3 pieces to it, it still has a leading degree that is 2. So it's a quadratic. And so you look, and in this one, we have to compare and see, is there a number that goes into both 15 and negative 5? I would say yes, absolutely. There's also at least one x in each of these. So I'm actually going to pull out a 5x, and then to figure out what's left over, you just still do your division part. So I'm still going to divide by 5. And then you'll just also have to figure out how many x's are left over. So like 15x squared divided by 5 would give me 3. And then I took out one of the x's, so I only have one x left over. Same thing with when I do negative 5x, I divide by 5, so I get negative 1. And then I took out an x, and so I don't have any x's left actually in this one. So that would be the GCF of this quadratic, would be the 5x. And then I have the 3x minus 1 left over. So it doesn't always have to look like it's in this form. You could also apply it to the same type of problem over here. All right. So now, because we've factored out the GCF of the polynomials, we can break them down even further. It tends to be a little hard at first, but it gets easier with practice. So quadratics, we want to always set up as the following, especially if it has 3 terms, but even if it has 2 terms, you want it to go from the highest degree to the lowest. So you want your x squareds to go first, then any regular x's you have, then any constants, okay? To factor, first and foremost, we want to be able to factor out a GCF, so we might have to do that in a couple of these, and then it says put it in parentheses out in front of the remaining polynomial. Then we want to figure out the pairs of numbers that multiply to give you C. A lot of times when we talked about this in Algebra 2, we also said we wanted to multiply to get you AC, but right now we're dealing with things where A is 1 only, so it wouldn't really matter. And they add to give you B in the polynomial. A lot of times we wrote this using your table, right? So what numbers multiply to AC and add to B value. The goal is by the end of us practicing this skill, you won't have to write out the table every single time, but it's there if you need it. So then we write our numbers or our factors in this following format, and then that is factored. Remember your GCF out front. A lot of people, when they pull that number out front, so like the 3 or the 4 or the 5x, they like to just like drop it completely and not have it anywhere in the problem. No, it is there. You need to include it. Okay. So let's go ahead and we'll factor these quadratic trinomials. So the first thing we're going to do is look and see, is there a GCF? Is there a number that goes into 4, 40, and 96? And if you're not sure, you can always check on your calculator. So like I know 4 goes into 4 and 40. I don't know if it goes into 96. And it does. Okay, so I'm going to go ahead and the first thing I'm going to do is pull out that 4. And then you can think of it as dividing. So 4 divided by 4 gives me 1x squared left. Negative 40 divided by 4 would give me negative 10x. And then 96 divided by 4, I had to check it in my calculator, is 24. Okay. So then if we were going to look at this piece, you want to figure out, we want to factor the remaining polynomial. So if you're going to use your table, you have to figure out what would multiply to A times C. So 1 times 24 gives me 24. And then what adds to your B value, what adds to negative 10, and you can just test or guess and check a couple of factors that get that there. So for example, I know like 2 and 12 multiply to 24, but they don't add to negative 10. Well, maybe if I make them both negative. Nope, still don't add to negative 10. So now I'm going to check another set of factors. I know that 3 and 8 multiplied to 24 don't add to negative 10. Even if I make them both negative, still don't. I know that 4 and 6 multiplied to 24. Now those add to positive 10, so if I make them both negative, they would in fact add to, oh, that's a terrible check mark. They would in fact add to negative 10. All right, so then those are my factors. So I have x minus 4 and x minus 6, and you can't forget your GCF that was out front. There you go. So then that would be your final answer for just factoring the trinomials. All right, I'm going to go ahead and do another example here. And again, ideally at the end of doing this skill, we won't need to keep using the table, but again, use it as a support if you need it. So the first thing we have here is we look and see if there's a GCF. So there's no numbers that go into negative 7, 8, and negative 1, except for a negative maybe. We'll try that. But there's a lot of D's going on here. So what I can do is I can pull out that negative 1 because I usually don't like this first term to be negative. So if I can get rid of the negative that's in the very front, that would be ideal. And then for this one, I have 4 D's in this scenario, 3 here and 2 here. So the most, or the ones that I can pull out from, the most that I can pull out from each term, excuse me, are 2 D's. So D squared. And then we write what's left over. So I took the negative off of this, and then I took 2 of the D's, so I have D squared left over. I took a negative out of this, so 8 divided by negative 1 gives me negative 8 with 1 D left over. And then negative 7 divided by negative 1 gives me a positive 7, and then I took both of those variables out front. All right, so I have my GCF. Now I'm going to go ahead and factor what's left over in my polynomial. So I will have, well, go ahead and write those parentheses because I know it's got a factor, right? What multiplies to 1 times 7 is 7. And adds to a negative 8. Well, there's not very many numbers that multiply to a positive 7. So if I do, for example, 1 and 7, those add to a positive 8, but if I make them both negative, they add to a negative 8. So I have D minus 1 d minus 7, and then don't forget your GCF out front. Awesome. All right, go ahead and try this next one. So factor the following quadratic trinomial. You can pause right here and go ahead and try. And now we'll go ahead and continue. So first and foremost, is there a GCF between 3, 21, and 18? Absolutely. If I pull a 3 out front, then I would be left with w squared, because you divide by 3. 21w divided by 3 would give me 7. And then 18 divided by 3 would give me 6. Awesome. And so then now I'm thinking, what are the two factors that would multiply to 1 times 6? So what multiplies to 6 and adds to 7? Feel free to use the table, but I'm going to try not to. What multiplies to 6 and adds to 7? Well, that would be 6 and 1, right? So my 3 is out front. And then I have w plus 6, w plus 1. All right, in this next problem, we're going to go ahead and do the same thing. So if there's a GCF first, I'm going to pull that out. So it looks like I have a negative that can go into every one. I have at least one a that's in every term, and then I think these are all divisible by 2. So I'm going to pull out a negative 2a, and then we'll figure out what's left over. I think I'm going to run out of room. So if you do negative 2 divided by negative 2, you just get 1. And then my a cubed, I took out one of those a's, so I have 2 of them left. Negative 20 divided by negative 2 gives me a positive 10. And then I took out an a, so I have 1 left. Then negative 50 divided by negative 2 gives me a positive 25. And I took out the only a that it had. All right, and now we're going to factor what's left over here. So I have negative 2a. And then to figure out what's left over, what multiplies to 25 and adds to 10? Well, there's only a couple of numbers that multiply to 25, so that makes it kind of easy. 5 times 5 would give me 25, and that would also add to 10. So a plus 5, a plus 5. Awesome. The other way that you could see this one written is, I'm going to go on to the next page, hopefully you still have space, is that if you have the same factor twice, you could see it written as a plus 5 squared. Cool. All right, I'm going to go ahead and pause here, and then once you take a little break, move on to part 2 of this video.